containing radicals. So we're going to look at radicals just like we were before break, but now we're going to have equations. So equations basically just means it's going to have an equal sign in it. All right? And when you see the equal sign, that usually just indicates to you, okay, so I just need to get the variable by myself. I'm just going to do inverse operations until I get there. Okay? So example number 1, we're going to start with the square root of 2x minus 1. We're going to set it equal to 3. All right? So on the left, we've got that square root. What's the inverse operation of square root? Squaring. So we're going to square this side, and if we square this side, that means we have to square this side. These are inverse operations, and they cancel each other out, leaving us with just 2x minus 1 on the left. And then the right's pretty easy. 3 squared is 9. Okay? That simple inverse operation gets it down to a pre-algebra problem. Right? From here, it should be a piece of cake. Add 1 to both sides. Divide both sides by 2. You should get x equals 5. Okay? Any questions on example number 1? All right. Example number 2. All right, so on the left, we've got 2 times the cube root of x minus 1 equal to 3. Okay, so you see the variable on the left, there's a couple operations happening to it. There's actually 3 operations happening. You guys see the 3 operations? Okay, one's being subtracted, it's being multiplied by 2, and we've got the cube root. So we need to undo all 3 of them. So I'm going to start by adding 1 to both sides. That leaves us with 2 times the cube root of x equal to 4. Then we've got the inverse operation of multiplying by 2, so we're going to divide by 2. That leaves us with the cube root of x equal to 2. And then the inverse operation of taking the cube root is going to the 3rd power, or cubing. Okay? So we're going to take this side to the 3rd power, which means we have to take this side to the 3rd power. Okay? These are inverse operations, so they cancel each other out, and we're left with just x. And then 2 to the 3rd power is 2 times 2 times 2. Should be 8. Okay? Any questions on example number 2? All right. So let's get a little bit harder here. Example number 3. All right, example number 3. You can tell right away it's going to be a little bit harder. Why? Because you've got square roots on both sides, okay? And you've got the variable on both sides. So you've got an x on the left side of the equal sign, and an x on the right side of the equal sign. Okay? Let's start by undoing this operation of square rooting. So let's square this side, which means we're also going to have to square this side. On this side, that means we're going to have this binomial. And if we square it, that means we're going to have to multiply the binomial times itself, the binomial, which means we're going to use FOIL, right? Okay? So we were doing FOIL a little bit before break. Left side, we're just going to cancel these 2 operations, right? So we just have 2x plus 5. Oh, I didn't mean to put the equal sign up there. We want the equal sign right there. Okay? So we've got the 2x plus 5. Now we need to FOIL this. So I'm going to write it out. I like to say 2 times the square root of 2x plus 1 times 2 times the square root of 2x plus 1, and then I'm going to FOIL it. If you want to use the box, use the box. Okay? So bring down the left side. And then on the right side of the equal sign, we're going to FOIL. So F is for first. 2 times the square root of 2 rad 2x times the square root of 2 rad 2x is going to get us 4 times the square root of 4x squared. O for the outside is 2 rad, that should be a plus, sorry. I wrote an equal sign, should be a plus. Then we've got the O outside, 2 rad 2x times 1 is one of them. And then I inside is the same thing. So we've got another 2 rad 2x. L is last, so 1 times 1 is 1. So these two middle terms right here are the two that are going to combine. So bring down the left side of the equal sign again. Let's see if we can simplify this one right here. We've got 4x squared underneath the radical. What's the square root of 4x squared? 2x. So we can multiply that by the 4 and get 8x. Right? These two are going to combine, so we're going to have plus 4 square roots of 2x. And then for right now, just bring down the 1. Okay. So we've still got this square root in here. So to inverse or to undo that square root, we need to get that by itself, kind of like we did up here in example number 2. We had to add the 1 and divide by 2 to get that radical by itself. So right here, we want to get this radical by itself again. So we can subtract 8x, and we can subtract the 1. You can do that in 2 separate steps if you want to. I like to do it in 1 step. So 2x minus 8x is negative 6x. And then 5 minus 1 is 4. These are opposites, and that gets us down to the 4 square roots of 2x. All right. At this point, we could divide by 4, but 4 doesn't go evenly into here, right? So that wouldn't help us as much. It would help us a little, but not really. So instead, I'm going to square at this point to get rid of that radical. So which means I also need to square this side. Okay, so on the left, I'm going to FOIL here. I'm going to have negative 6x plus 4 times negative 6x plus 4. And then on the right side of the equal sign, I've got 4 rad 2x times 4 rad 2x. So what's 4 times 4? 16. And then underneath the radical, 2x times 2x would be 4x squared. So just like up here, when we took the square root of 4x squared, we got 2x. 2x times 16 is 32x. And then on the left over here, we need to FOIL. So this is our second time foiling in this one problem, right? Okay. So F is for first. Negative 6x times negative 6x is going to be positive 36x squared. O is for outside. So we've got negative 6x times 4, which is a negative 24x. And then inside is the same thing, another negative 24x. L is for last. 4 times 4 is 16. Okay? So again, our two middle terms right here are our like terms that can combine. So we've got 36x squared. These two combine to get negative 48x. Bring down the 16. And if we set this equal to 0, we can factor, right? So let's let's subtract this 32x. That'll set it equal to 0. Okay? So bring down the 36x squared, and then negative 48x minus 32x x more is what? Negative 80x plus 16. So now we have this nice trinomial. Notice that all the radicals are gone. So you want to eliminate that first. Now we need to factor this to get our solution. How many solutions should we have? Remember, there's a hint. Look at the exponent. So how many factors should we have? Or solutions? We should have 2. Okay? First, look to see if there's a GCF. Yeah. So I'm going to pull out a 4, which will leave me with 9x squared minus 20x plus 4. And then if I divide by 4, the 4's cancel. I get 9x squared minus 20x plus 4 equals 0. Okay? Is this easily factorable? No. So we are going to have to use the slip and slide. Okay? So we want to multiply the 9 times 4. That's going to give us x squared minus 20x plus 36. Sorry, I just like to write that there, otherwise I forget to do it. Now we want to factor. What 2 numbers are going to multiply to get 36, but add or subtract to get negative 20? Yes, 18 and 2, and they're both what? Right. So x minus 18 and x minus 2. We need to divide both of those by 9. Divide by 9. Okay? So this one's pretty easy. This one simplifies, right? This is just going to be x minus 2. But this one, we need to use our slip and slide rule. So we're going to have x minus 2. And then this one, the 9 slides out front. We're going to have 9x minus 2. And then we just need our solutions. So right here, remember, these are our factors. Our solutions, running out of room, are going to be the opposite. This one's easy, right? What's this one? 2. So x is equal to 2. And then this one is going to be a what? It's going to be a fraction, right? See, because it has a coefficient of 9. So if I take 9x minus 2, set it equal to 0, add 2 to both sides, we get 9x equals 2, divide both sides by 9, so x equals 2 ninths. X equals 2 ninths. All right. Finish copying that down. Are there any questions on that one?